we care about. Now, the second part of setting up the metrics is figuring out what is our region of practical equivalence. What does it mean? It's the region for which we know that the model is good enough, or we see that, let's say, our performance on the test set was 0.85 for OKUC. Let's say that we're okay with dropping 5 percentage points, and we're just gonna put 0.1 to 1. Then there is other parameter called the required 95% HDI width. What is metric used for? It is possible that when you deploy the model and you only get, let's say, first few hundred predictions, just by sheer luck, your model performance will be lower or higher than expected and long-term performance of your model. So what is HDI width? Let's first define what HDI is. In our model evaluation framework, we're using robust Bayesian statistics to ensure that the information you get as early as possible, and you can actually trust the results of the experiment, of the pilot. And one of the most important parts of a Bayesian hypothesis testing is so-called highest density interval. When we run our Bayesian experiment, we're gonna get a posterior distribution of where the actual value of our metric lies. So let's say for OKUC, we're gonna get a curve, and HDI is simply the region where most of the data points or most of the probability density lies. Now we want to make sure that this width is small enough such that we avoid any potential just random effects that would move the HDI potentially away from the rope. So then we would say that the model performance has decreased, where in reality that is not necessarily true.